Okay, so here's a clip regarding the Math Studies internal assessment. What I'm going to talk you through is how it's marked, so how our marks are awarded. But the examples that I'm going to give you are the most common sort of type of investigation that most students end up doing, which is a statistical based one. Now you don't have to do a statistical based investigation if you don't want to. There are plenty of other examples online, but this is just the most common one. I'm going to talk you through how you can get marks and how to go about it and the general structure of it. If you want to look at examples, there's a link below this clip which will take you to this page here, and it's got information about how you can plan your internal assessment. It's got the marking criteria as well in detail and including examples. So for example, in criteria D, if you want to know what a 1 mark on criteria D is, you can click that example. And also down the left hand side here, it's got lots of different examples. You can click them, you can look at the student work, or you can look at the annotated. So if I click that, this is the mark. The student got 6 marks out of a possible 20, and if you click that, this is the PDF of the project with the annotations, and here it's got what mark, how the marks were awarded for each criteria from A to G. Okay, so that's not the best example. Let's look at example 12. It's 9 marks, it's not any better. But anyway, you can have a look at that if you like. So that link is below this clip. Okay, so what I'm going to show you now is the marking criteria, and I'm going to base it around the most common sort of type of internal assessment I've seen, which is like a stats-based one. Okay, so statistical analysis. Okay, so let me just talk you through the criteria very quickly, first of all. So the criteria is based on the following things. You get a mark awarded for your introduction, for your information and measurements, that's like your data. Then criteria C is your mathematical process, so what maths you've done. Criteria D is how you've interpreted the data, so your analysis of it or your conclusion. Criteria E is like a validation of how well you think you performed, the limitations of your project. So, you know, what kind of pitfalls, what kind of errors could have happened. And then criteria F is how you structure and you communicate your project. So, you know, how well is it written, the structure of it, have you included the footnotes, bibliography, that sort of thing. And criteria D is the notation and terminology. Okay, they are all worth different amounts, but the grand total, it's out of 20. Okay, right, so let's begin. Criteria A, your introduction. So this is the maximum you can get here is 3 marks. Okay, so if I just read it briefly to you, it's, by the way, the PDF for this is at the bottom of the clip, so you can download that. The project does not contain a clear title or task. You get 0 marks. You get 1 mark for having a clear statement of a task, 2 marks for having a title and a statement of a task with a description of a plan. The plan may not need to be detailed, and 3 marks is awarded for having a title, a statement of a task, and a detailed plan that is followed. Okay, so what it means by that is just, you know, have a clear title for your project. Think about what you are investigating, and write that in the introduction. And what are you investigating? How are you going to do it? Okay, that will give you 2 marks if you just include those things here. But the way to get 3 marks is to be specific. So if you have a title and a statement of a task, what you're investigating, and a plan of how you're going to investigate it, but you want to be detailed. Okay, so to get the 3 marks, you want to have a detail. So you may want to include how you're going to collect the data, what maths you are going to perform, and why. Okay, so you may wish to state a hypothesis as well, so what result you may hope to achieve. So in this example, okay, so this person has got a clear title here. Is there a relationship between a country's GDP and the life expectancy at birth of its population? So you've got a clear title here. That's 1 mark. Okay, now the introduction is split over a couple of different areas. Okay, so it's not like one thing that says intro. It's got introduction, a plan, very clearly stated, and the hypothesis as well. Now I won't read it all out to you, but in the introduction he talks about what he wants to investigate. Okay, what they want to investigate, and a reason for it. Okay, so the person was interested in world affairs because he's done a lot of traveling to places like China, Russia, and Kenya, and so it was an area of interest for him. And then he talks about how he's going to investigate it, and this is where he can get the 3 marks. Okay, because first of all he talks about how he's going to collect the data, specifically where he's going to collect the data from. Okay, and a really detailed description. So what the student does is they do a stratified sample. They're going to choose 50 countries based on how many countries there are in the continent and so on. So it's a very detailed description of how he's going to collect the data, first of all. Then he talks about what he's going to do and why. So they're going to do a scattergraph first of all, and they're going to talk about linear regression. They're going to do a linear regression on it, Pearson's product moment correlation coefficient. They're going to calculate that, and they're going to do a chi-squared test, and also the reason for it. Okay, now most of these statistical data, now this is the important bit, most of the statistical data, the statistical investigations are based on 2 variables. Okay, so the 2 variables here are GDP and life expectancy. Okay, so the 2 variables here, and I'll give you another example of what somebody else has done. Sorry. This person has decided to do it on the height of an athlete and the time taken to run the 100 meters. Okay, so he's basically gone and got all the records from, I think, 1896 of the athletes that have achieved gold medals, and he has collected their height and the time taken, which are 2 separate variables, and they're going to do an investigation on that, okay, to see whether there's a connection between the 2. So does a taller person achieve a faster time? That was their investigation. And one more, this is not the best one, but does the death rate of a country affect the country's GDP? So this is to do with I think how many people die in their GDP. So there's 2 variables again, okay? But going back to the first one, this one was the best one in terms of it's got a really detailed plan of how you're going to collect the data, what calculations you're going to do, and why. And it's got a brief sort of hypothesis, which is not really awarded anything, but it might be worth including. You know, what the expected outcome would be. So that's criteria A. Okay. Criteria B is about the data, the information, what you've collected. Okay. Now, 0 marks is for project does not contain any relevant information at all. So 1 mark is the project contains relevant information collected or relevant generated measurements, and 2 marks awarded for relevant information collected, set of measurements generated, and the data is organized or is sufficient in both quantity and quality. and 3 marks are awarded for data which is relevant, organized, and is sufficient in both quality and quantity. Now, how to get the marks here, okay? I'm going to give you 2 examples here. So for example, here's a bad example, okay? This student has collected data regarding the death rate of the population and the GDP in billions, but it's really done badly because first of all, there's no description of how the student collected the data. So I think he just says he randomly selects countries, which is not good enough really. And it hasn't really explained what it means by death rate. I'm still trying to understand what it means by death rate. It's confusing, so it hasn't explained that bit there. And it's not very neatly organized. First of all, these numbers are rounded to different decimal places, so that suggests to me he's just copied and pasted it off the internet, hasn't really thought about it. Like for example, some of the numbers are to do 2 decimal places where some are rounded to the nearest whole number, but there may be a legitimate reason for that, but they haven't explained it. And the most important thing is they haven't explained how the data is collected. It's not organized very well, okay? Now you could choose to organize it by, you know, highest to lowest in a particular column, but the one main thing is that the person has got repeating data, so he's got Bulgaria twice. So here's Bulgaria at the bottom, and then somewhere up here is Bulgaria again, but with different numbers for some reason. And I think that's a genuine error, but I'm not quite sure the reason for that. But that hasn't been explained, or so it's carelessness. So it's not. The quality of the data is very poor. Okay, going back to the better one. Okay, so this is the better example. This data is very clearly organized. Above here it's got a detailed explanation of what it means by GDP of a country and the life expectancy at birth, and it's organized in a way that it's done by continent. Now that wasn't very clear, so it probably was awarded 2. I think I awarded it 2 marks rather than 3 because it is clearly structured, but the student has done it by continent. We could have explained that a bit better. But the best thing about it is that there's a detailed description in the introduction of how the data is collected, and he did a stratified sampling, okay, which is very good. He didn't just randomly select the data, he did a stratified sample. Now there are different ways to collect data. You don't have to do a stratified sampling, but you need to give a legitimate reason, okay. Now you could also do a survey, okay, so one person, for example, did one based on how quickly you could type a text message and your age, okay. So they basically had a block of text that a particular person needed to type, okay, on their phone, using the old-fashioned, you know, A, B, C. You had to press the number 1 twice to get a letter B or something like that. How quickly you could type, and recorded the age. Now, the only problem that they encountered was that they didn't pick students correctly based on age, so they didn't pick like 10, 11-year-olds and 10, 12-year-olds and so on. They just randomly selected people, and I had to go back and do it again. Now, so be careful. You don't have to just go on the internet and get data. You can do an experiment. One person did a correlation between the length of their foot and their height, and did a statistical test on that. One person did a test on memory and age, so they basically had a block of data that they needed to memorize. and how old they were. One person did, they had a jar of jelly beans, for example, and they needed to estimate how many jelly beans there were, and I think they did that against age and seeing if there was correlation. That wasn't the best one. I don't think they got very good results on that, but it was, it's a good idea in principle. So you don't have to just go online and get data. You can actually go and do a test of some sort. Okay, but quantity as well is important as well as quality. So the student here has picked 50 countries. Now it's up to you how many you pick, but 50 is a good number. I would, probably maybe do a bit more than that. 100 is probably better, but it's up to you. Okay, 50 is a good round solid number, but you need to give a reason for that. And I think somewhere in the introduction he gives a reason for why he has decided to choose 50 countries rather than maybe doing 70 or 100 or whatever. So quantity is important. Okay, that's criteria B there. Okay, so let me go back to that. So you've got sufficient in both quality and quantity. The data's organized. How you sample the data is very, very important. That really kind of pushes it towards a 3 if you talk about how you collect that data. Okay, so moving on to the next thing, the mathematical processes. Now this is worth the most marks. So it goes from 0 to 5. Okay, now let me just start off. Okay, I'm not gonna, basically if you do practically nothing you get 0 marks. Okay, so for 1 mark you at least attempt 2 simple mathematical processes have been carried out. Okay, and it talks about what a simple mathematical processes here are. So simple processes are considered to be those that are things along the lines of percentages, working out area, graphs, bar charts, pie charts, calculating the mean, standard deviation, substitution into a formula, any calculations with graph or using technology, right? Okay, those are classed as simple. Now, only 2 of those is fine. So you just basically carry them out. But where you get 2 marks from is whether you do those simple processes, but you do them correctly. So let's say you do standard deviation. If you do it correctly using the correct formula and you've got no errors, and maybe you use your calculator to check your work, then you get 2 marks for doing them correctly. Okay. If you choose to do sorry, I lost my train of thought. So criteria 3 is to do simple processes carried out correctly, but they are relevant. Okay, this is the important word, relevant. So there's no point doing a pie chart, for example, if there's no purpose to it. Okay, or there's no point doing standard deviation if it doesn't help towards your investigation. So in your introduction you would state why you do those particular calculations, right? So you would say in your intro, I'm going to do standard deviation because it's going to help me to see the distribution of data, to see the spread of it, or it's going to help me compare male versus female or something like that, or whatever. But it's got to be a relevant reason for it. Okay, so this feeds on from your introduction. So doing 2 simple processes, but they are relevant to your project. Okay, that's important. That's worth 3 marks. Criteria 4 is where we look at the further processes. Okay, so you've got things like differential calculus, modeling, optimization, exponential functions, stats tests, distributions, compound probability, a whole load of things. But again, the criteria 4 is that you carry out at least 1 further process. And it says for this level to be achieved, it's not required that the calculation of the further process be without error. So you can make a simple mistake somewhere. If it's like a really, really bad mistake, you probably won't get a 4 for that, like a really obvious stupid error. Okay. You must show your full working, so any calculation you do, by the way, you must do it by hand. You can't just type it in to the fancy calculator and press enter and then just write down the result. You can't do that. You must do it by hand. Okay, I'll talk later about how you can do it by hand. Right, and then criteria 4 is to do those further processes, but doing it correctly without any errors, Okay, so that's criteria 5. And also, if your data is limited in scope, then you can't get a 5 here. So that means if your data, going back to criteria B, if your data is rubbish, then there's no way in hell you're going to get a 5. Okay, so your data needs to be good. Now, let me just show you this PDF that I will put at the bottom of the page in the document section. Talks about the standard skills. Sorry, this should be changed to simple processes. So let me delete that. I'll save that now. So things like scatter diagrams, frequency tables, standard deviation, simple processes. A further process. Oops. These are further processes here. Things like line of best fit and correlation, so things like Pearson's product moment correlation coefficient, linear regression coefficient determination. If I were doing Pearson's, I probably would do all 3 of these. Now, Pearson's product moment correlation coefficient you must work out by hand. Okay, and then the chi-square test. Okay, now I've put here in brackets, if the degree of freedom is 1, then you need to do Yates continuity correction formula. Now, this is important. If your degree of freedom is 1 and you don't do Yates continuity correction, it doesn't matter if you do it correctly and your data is fantastic, you will only get 4 marks. You will not get the 5. Okay, you must remember that you need to do every calculation by hand. But things like scatter diagrams and bar charts and pie charts, you can get Excel to do them. You're not expected to draw a scatter diagram by hand. Okay, but things like standard deviation, where you need to calculate something, or the mean, or the median, or something like that, you should probably work them out by hand. Okay, so you should really do that by hand, or percentiles or percentages or that sort of thing. And again, cumulative frequency curves, if you're going to do one of those, you're probably best to do it on graph paper so you can read off some percentiles and make some analysis, right? So that's criteria 5 in a nutshell. So you've got your simple processes, you've got to do at least 2 of them. If you do it correctly and they're relevant, you get 3 marks. You need to do at least 1 further process. Most people end up doing both Pearson's and chi-squared. It's up to you which one you want to do. It does say at least 1. If you want to be on the safe side, probably do both. So do that. You get 4 marks. If your data is good and you do it correctly, you will get the 5 marks there. Okay. And also remember, if your degree of freedom is 1, you must do something called Yates's continuity correction formula. I'll talk about that later, and then you can get a 5 mark there. Okay, going back to this, right? Criteria. What are we on now? Criteria D, interpretation results. Now, okay, this is in terms like a conclusion. Now, this is like you analyzing your results. Okay, it's not a good thing to do all the analysis at the end. Okay, now what I said to my students is that a rule of thumb is that every time you calculate something, discuss the result. Okay, so here, for example, this is the better project. The student calculates the mean. Okay, so he's got the formula for the mean, nice and neatly stated there. he has got an example of, he's calculated the mean several times, but he's given one example which is okay. And there's the data summed up here in a nice neat table, and then directly below it he's analyzed it. Okay, so this is a detailed description and analysis. Now that goes through the entire project, so every time the student has done a calculation, so for example, here's the standard deviation being calculated, here's an example of standard deviation, here's the table of all the different results, and underneath is an analysis and interpretation of the results. Then he goes on to do a scatter graph, and underneath he's got description, analysis of it. Then he calculates Pearson's. Here's a table of calculation, here's the result. And then directly underneath is a detailed description of the interpretation of it. And then here's chi-square test, how you perform it. Here's the result somewhere. Let me just do this. The result is somewhere down here. Okay, it's here. That's the result. And there's the evaluation of the result for chi-squared. And then at the very end, it's all brought together in a final conclusion. Okay, and that's the best way to set out an interpretation. It's got to be flowing through your project. So every time you do something, interpret the result. Okay, now how the mark is rewarded. Okay, if you basically write some utter rubbish that has no evidence to back it up, and it doesn't reflect the results that you've got, you get nothing. So for example, let's say your data shows absolutely nothing, no correlation whatsoever. So you do all your tests and it comes back with nothing, right? Literally zero. Like let's say Pearson's ends up being 0 for example, but then you go on to say, oh, there's a slight hint of a correlation. Then that doesn't make any sense because it doesn't match the evidence that you've just worked out. Okay, there's no evidence to back it up, so you get nothing. Okay, you get 1 mark for at least one interpretation or conclusion. Okay, and only minimal evidence of interpretation and conclusion is required for this level. This level can be achieved by recognizing the need to interpret the results and attempting to do so, but reaching only false or contradictory conclusions. Let's say you kind of do results and you interpret it, but the evidence doesn't quite back it fully, and you get 1 mark there. Criteria 2 is kind of like the most common thing that most people get, is the project contains interpretations and conclusions that are consistent with the mathematical processes used. So for example, the student on this particular project got a Pearson's product correlation coefficient of 0.5 and he made a relevant analysis of that. But I'll give you an example of a not so good one. So here, so for example, look at that scatter graph here. It's terrible. You've got this outlier right up here and everything is skewed down here, and it doesn't look like anything, and the data scale is all wrong. It's terrible. There's no interpretation, but the Pearson's product correlation coefficient is minus 0.08, so practically nothing. And then they've got a really, really simple conclusion here. So I think that ended up with possibly 1 mark, because he said one relevant thing. Can't remember what it was. Something about scatter graph being skewed or something like that. So that's an example of a 0. And you saw an example of something that I gave a 2 to, right? The one before. But let me just go back. To get a 3 is very difficult. Okay, to achieve this level, it must have a meaningful discussion. Okay, and obviously it needs to be consistent with the results the mathematical processes use. Okay, I'll just read it out to you. It says that to achieve this level, a student would be expected to produce discussion of the results obtained and the conclusion drawn based on the level of understanding saying reasonable to be expected from a student of mathematical studies. Okay. Now, underneath it says, if the project is a simple one with few opportunities for substantial interpretation, this achievement level cannot be awarded. Now, unfortunately, I recall I did award this student 2 in this section, even though, you know, it's a good project because of the way it's structured and the way it's written and the way things are interpreted, but it's the nature of the project. If I just go back to the title, they're investigating GDP against life expectancy, and it's kind of obvious what the result is going to be. So the project is simple in nature, so there wasn't really much scope to go into much detail. It's difficult to come up with a project that has something really, really fascinating to kind of discuss. So think long and hard about what you want to kind of investigate from the beginning, okay? Because you're going to have to talk about the results, and you don't want to waffle. And then in some places, he's like, the student's saying like the same thing in like 50 different ways, which is kind of like waffling, really. You want to be concise in the interpretation, okay? That's an important word. Okay, so in the interpretation, you do want to be concise, so don't waffle, don't repeat yourself, don't say the same thing 50 times. You know, say it concisely, and then think about a project where it's kind of really interesting. I think one person did something about crime rates across America and the different states, and looked at the I think it was to do with employment of each state and crime rate, which is really, really good, because, you know, there was a big problem in America with you know, people getting shot, you know, and they went on to discuss about how there was a correlation between the crime rate being really high where there was low employment. So there's something to do with people being employed and the crime rate being low, and then they went on to look at, discuss how that affects society, and it was really, really detailed, really good, but it was a gripping investigation. So think about what you want to investigate first of all, because the interpretation, it's quite straightforward to get 2 marks, but it's really, really difficult to get 3 marks. Okay, it really depends on the nature of the project. Okay, but remember, it's got to be a running commentary all the way through. Okay, validity. Now this is a really, really difficult thing to get right. Okay, it's only worth 1 mark, but it's difficult, and how you achieve it is now you need to remember, it's different from a conclusion. It's not about your results, nothing to do with that. It's how you've conducted your project and how well you feel you've done, the limitations of it. I'm going to stress the word limitations. It's not good enough to just say something along the lines of, I should have got more data, or I should have done more surveys, I should have tested more, I should have tested it more times, or something like that. That's not good enough. Okay, you need to really think about the limitations of your project. Think about things like the accuracy of your data, whether you, for example, I'll give you an example of something you could discuss. I mean, this is something maybe you could discuss with your teacher, because I'm not the best at this, but for example here, if you look at this student's data, they decided, because when they went online and they got the data was rounded to different values for each country. So they decided to round it to 3 decimal places, and they've put that in the introduction that they've rounded it, and each life expectancy has been rounded to the nearest whole number. Okay, and then later in the let me go back to the bottom. Let me go to the bottom. In the sort of the validation, the sort of evaluation of the project, they talk about the limitations, and somewhere down there they talk about whether that rounding to 3 decimal places would have made much difference or not to the calculations, and they kind of justify that the error in rounding would have been really, really small, and Pearson's would have been accurate. And then they actually they talked about how they basically got the raw data and ran it through Excel, and the Pearson's value for that was very similar to what they got, and it was hardly any different. So they talked about that here, which is that's why they got 1 mark here for that. And also, for example, one person did an investigation on. Remember, I said it was like typing a text message and how old you are and how quickly you can type it. And they talked about how they basically got a bunch of students to do it, but one of the problems they encountered was the time of day that they did it, because when they did it in the morning with like the younger kids, like 11-year-olds, they were quite fresh, minded. They were enthusiastic and they were really up for it. But when they tested some students later in the afternoon, sort of at the end of school, they were sort of tired, a bit lackadaisical, wanting to go home, not really focused. So it could have skewed results. There's some discussion there. Okay, it's a difficult 1 mark question to get. So, sorry, difficult 1 mark to achieve. Okay, so you need to really think about what the limitations of your project are. I mean, there's just 2 examples, but discuss with your teacher about what you could include if you wanted to. Right. Criteria 4 is to do with the structure. Okay, it's worth a maximum of 3 marks. Oops, gone past it. Okay, structure and communication. Now, your project needs to be complete, obviously, so everything you said at the beginning in your introduction you must finish. Okay. There must be a logical development. Okay, so for example, you wouldn't want to do something like Pearson's first. You probably want to do that at the end. Yeah, you want to do the simple things first, like calculating a mean or something, drawing a scatter diagram or something. Then you want to go on to Pearson's and chi-squared, and you do the easy first stuff, then the difficult stuff later. So think about the logical way you want to conduct things. Okay. And it's got a flow as well, so one thing's got to lead onto the other. So I talk about connecting different areas. So the great thing about this student's work, this really, really good piece of work, is that briefly, at the end of each section, he talks about what he's going to do next and why. Or he gives a brief introduction of why he's going to do that. So somewhere down in this section here, he talks about going on to do a Pearson's test, and the reason for it is because it looks like there's a very good correlation here, so you're going to do Pearson. So one thing connects to the other, and that's important because that's kind of like the flow of the project. I mean, it's about a logical manner to the thing. Okay, it's something that someone can easily follow. Okay, so comment on the things like that. Now, things like let me just check my notes. What did I say? Okay, things like structure important. That it follows the plan that you stated at the beginning and is communicated in the current manner. So that means it must read well. So don't, for example, this project, which was not very good, did not read very well. There was too many grammatical mistakes. Some sentences didn't make any sense, and it wasn't proofread by anyone. I mean, don't really expect your teacher to proofread it for you. Remember, you get one go at this. So on the first kind of draft of this, I highlighted some mistakes, but then it wasn't a complete project, and the student handed me the final draft with some additional bits which I'd never seen before, and I didn't have a chance to kind of check any grammatical errors, and unfortunately, tough luck, So what's marked is what you hand in on the final draft. So he didn't get much for that last section. It's got to read well. Okay, remember it's got to be a running commentary. The order of calculation is important. Okay, now Also, footnotes. Okay, these are important as well. Footnotes and bibliographies. Okay, so here, let me give you an example. Right, right. Let's just see. Right, let me give you an example of a really, really good footnote. Okay, here. The best thing to do is probably follow the method that you used in your extended essay for referencing things, and you can't go wrong really. So basically the student has collected some data, and down here he's referenced it in the footnotes of where he's got the data in the same format as you would do the extended essay. So that's important. You know, it's just follow that same format, you can't go wrong really. It's done in a footnote, and also if I go to the very end, okay, so, oh no, this one's not the one, but no, this is the wrong one. There was another, by another candidate, they included a bibliography and an appendix where I think they put a copy of a survey that they used to collect their data. So bibliography is important. Now, this is just a PDF copy of the project, but the paper copy that was handed to me had a title page to it as well. So I mean, that's just to kind of jazz it up, and I think he put it in one of those plastic folders as well. I mean, you don't need to do that because I take it out of the plastic folder and hand the whole thing in a plastic wallet with the instructions on front to the examiner anyway. But it's up to you what you include, but make sure you include footnotes, bibliography, and you reference things correctly. Okay. Structure is important. Things like overall conclusion should be at the end, and your evaluation, limitations, that sort of thing, should be at the end as well. Oh, okay. Now, the last criteria is the one for notation and terminology. Okay. So it's only worth 2 marks. It's quite easy to achieve if you remember certain things, right? Terminology is like using the correct words to describe things. So for example, if you do a scatter diagram saying things like moderate positive correlation, strong positive correlation, things like that, or I can't think of anything else. You know, just using the correct word, okay? Correct terminology to describe things. Notation is important. So, for example, let me go back to the good project. Okay, here, for example. This student has not only put the formula for chi-squared, but he has declared the variables. Okay, so he has put what f0 actually means, because it's very easy to forget that, okay, you know what f0 means, but does the person reading your project know what that means? Okay, and you know, just clearly define your variables. Okay, somewhere above here, for example, here, let's see, for example, x bar is the mean. Okay, he's put x bar equals the mean somewhere below. So that sort of thing, declare your variables, right? Also on your diagrams, now remember you can use Excel to draw your charts and bar charts, but the great thing the student has done, he's got a clear, obviously a very clear title on the bar chart, on the scatter diagram, a graph to show the relationship between life expectancy and birth at GDP in 2012. It's pretty obvious what the chart represents. The axis is labeled really clearly on both. There's a line of best fit, and the data points are clear as well. So, and you know, it's we have color printers in our school, so he's printed out in color, so it does stand out a bit more. These points, think about those things. You do want your charts to be quite clear as well. Also, you can, I'm not sure, you can sort of like have like, for example, if you draw your scatter diagram by hand, then you could obviously have it an extra page in the middle of your project, but make sure it's neat. I've seen some really scruffy bar charts before, and charts before. I'll just go back to the not so good one here. For example, things are not, this is really bad. Make sure you use Word to declare your formulas, because this sort of notation is not good. Okay, that is awful. Okay, that is not very good. That will not get you anything. I'll go back to the good one. This is what you want. Okay, look how neat that is. That looks almost, well, it is almost identical. It is, sorry, identical to what you see in a textbook. Okay, but use Word for that. In a later clip, I'll show you how to do that. Okay, if you do something like this, you don't get anything. Okay, if you do this, you may get something. Okay, but you need to do that throughout. And then obviously formulas. Look at the formulas. They are, it's like identical to what you would see in a textbook. Okay, neat. Use the formula editor for that. Okay, in Word. Do it in Word because it's the easiest one to use. So, just to sum up, label your diagrams, state your variables clearly, use the formula editor to show clear formulas. Oh, and by the way, reference those formulas as well. So here, look, at the very bottom, just as I said, this reference to the textbook that we use in class, and the page number 343. Okay, and the edition as well, which should have been, actually that's missing. That's edition 3. So there, that's how the criteria. That's how you are awarded the marks. Okay. So, oh, sorry, going back to criteria G. So the correct mathematical notation and terminology are used, whereas either, like, you can get the terminology wrong, but the maths notation correct and get 1 mark. So it is a little bit. It's quite easy to get the 2 marks if you just follow the basic stuff. Okay, so that's the sum up of how the thing's marked. In the next clip, I'm going to talk about how you can get started with your project, and we'll go from there. Okay, so hopefully this was helpful.